for good morning, and thank you very much for this very nice welcome. I'm very happy to be here with all of you, and I hope you enjoy this conference and my speech. And today I want to talk to you about legacy software and how we can live with this old software that even some people before us started to program, and we just inherited them, and we somehow have to deal with them. I will raise questions such as, what is good and what is bad legacy? What should we do if we have bad legacy? What is the way out? Should we refactor it or should we replace it? And how do we refactor it? For a short answer, I put this little comic on my slide. It's a comic of Geek and Poke. Geek and Poke is doing a lot of comics on software development, and it's called Best Practice in Application Architecture. Today, use layers to decouple. And in the comic, you see two architects that are discussing their architecture, and one of them says to the other, and every year we mount a new layer to decouple us from the crap we've done the year before. So this is what a lot of people do. But the most fantastic thing about this joke is the line underneath that says annual rings. You probably know that now the word is missing. The trees, of course, a very simple word, but anyway, the trees have annual rings. And if they have huge annual rings, we are very happy, because this means that the tree has had enough water and was growing and growing over years in a very good environment. But for software, this is actually a little bit of a problem, because if every year you have a different type of design of architecture in your software system, because you have annual rings, then they are very hard to understand. Then they are really legacy code. And well, this is why I really love this little joke. And before I dive into the topic, I have two short slides about my company and me. My company is called WPS Workplace Solution, and we, of course, like most of you, develop great software. Our focus is on amazing UX design. This is our name. We create workplace solutions, and this is very important, a sustainable software architecture. We started in 2000 with 12 developers, and as you can see here, we have grown. Since then, we have grown to 130 developers, and of course, at the moment, as you can see as well, we are all at home, but slowly every day, some of our employees start to return to the office, and I didn't expect that, but I'm enjoying it so much to meet people in person again. It's really amazing, and I hope very much that we will be able to meet each other soon again, personally on a conference or wherever. This is really, it was lacking for such a long time, and it's so great to meet again. So see you soon, I hope. I have studied computer science in the 90s of the last century in Hamburg at the university. And after that, I did a lot of software development in C++, Java, C#, you name it. And around 2000, I started to be project manager. Some people called me an architect, and I did a lot of consultancy as well. And in 2008, I finally wrote my doctor thesis, late, but nevertheless, with the title Complexity of Software Architecture. And this doctor thesis was based on 26 case studies of software analysis. And since then, I have made this a business in our company. We analyze legacy systems, we evaluate their complexity, and we help development teams to transform their often very complex legacy software into a system or systems that make maintenance really fun again. And this is a little bit what I want to talk to you about. Let's start with the question, well, what is good legacy software then? Well, from my point of view, what we want, if we want good legacy, we want our legacy to have a long and useful life, and thus pay off our investment that we did in the first place. And this means that we want actually the lowest possible maintenance cost and extension cost. We want the software to be in such a state that we can quickly, with not much money, change and extend it. And for that, I would sum up, a good legacy is something that is easy to understand, the architecture, the design, where I find which functionality implemented. So easy to understand, easy to change, and easy to extend. This is the goal. And if your legacy software is like that, then of course the cost for maintenance and extensions are low and our investment will pay off. So this is all related. But unfortunately, many software developers experience something quite different in their daily work with their legacy. Their daily work is characterized by a legacy software that looks more like this one here on the screen. Hard to understand, hard to find your way around. You don't even know where to get in or out. It's hard to change, it's hard to extend. And why did this happen? Well, the system was developed over many, many years, and new parts were added every year by a bunch of different developers, often in a rush because the client, the user were calling for this extension. And because the developers had no time, only the new parts were built into the system, and the old parts were not properly adopted, not changed, not lined up so that the whole system had one proper architecture. And so step by step, the architecture has become worse and worse. And we say today the architecture has eroded, and inside of the system, we often find structures like this one. This is a large tangled class cycle of 463 classes, and they belong to 10 different components. Each rectangle you see here in this diagram is a class, and the color of the rectangle indicates to which component this class belongs. So we have some blue ones, some green ones, some purple ones, and orange ones all over the place, as you can see. The relationships between the classes, so to say, one class calls another class or uses the type, the other class as a type. All these relationships are the arrows that you can see between the rectangles. There are many relationships, as you can see, especially in the middle. Everything is full of arrows, so that some areas are even displayed almost dark, in a dark black color. It is actually, if you have something like this, it is really difficult or almost impossible to remove a class from this cycle, because some other classes need the functionality of this class. In domain-driven design, we call this a big ball of mud, these interwoven structures that are so hard to find your way around and to change and to know about. But how did we get there? Well, the main reason why software becomes so interwoven over time is that software teams fail to distinguish between essential and accidental complexity. What is this? Well, essential complexity is inherent in the nature of the problem. There is complexity in the domain itself. For example, the routing for cars and bikes can become very complex from an algorithmic point of view, whereas the management of apartments, where you are mainly collecting data, has less essential complexity. this complexity arises when we model the domain, because we have to decide how to design our domain model classes. When we develop the architecture, new complexity arises, and when we decide which technology we want to use. So I have to tell you, you will never get rid of this essential complexity. It is essential. It will always be there. On the other hand, the accidental complexity is not necessary. That is built into the software because we have some misunderstandings about the domain and the technology, and this leads us to superfluous elements that we build into the solution, things that nobody will ever need, but we just understood that somebody could need it, or that this is a part of the domain that we have to develop, because we create awful design like this cycle that you have just seen, many things tied up together, high coupling, not a good cohesion in the classes and modules, and of course bad architecture if we don't divide our systems into proper modules, bounded context of domain-driven design, and of course as well if we do not master our technology, with it, which is from my point of view an ongoing problem, because our technology ages. You have probably all experienced that in your lifetime, that you started with some wonderful technology, and after some years you say, oh, now this is outdated. I still remember Struts web interfaces that we have created, and we had to get rid of them, and we had to move on to Angular or React or something like that. So this misunderstanding of the technology, or this misuse of the technology, can as well arrive over time if we don't decide to get rid of this technology. So accidental complexity is something we can avoid if we really take care of our design, of our architecture, and of our understanding of domain and technology. Good legacy, thus, has a small amount of accidental complexity. Let's have a look at the life of a software system and how complexity develops over time. In this diagram, on the x-axis, you see accidental complexity. This is the only complexity that we can do something about it, and we want to get it down to low, but sometimes we have high accidental complexity. And on the y-axis is the functionality that we are able to create per time unit or per budget. Imagine we have the world best team of developers, wonderful product owner, and a good management that understands software development. And then we might be able to develop and maintain our software in this corridor of low and stable maintenance cost. When the user is working with our software system, he will definitely find bugs, and hopefully he will have new ideas for new functionalities, because he loves our system so much and he wants to work more with it. And then we maintain and change the software. And as the first solution for an extension or for repairing a bug is rarely the best one, we will build in some accidental complexity when we are working on our software. This is why there are these yellow arcs that go, these yellow arrows, I wanted to say, that go upwards. There we have put in some accidental complexity because our first solution was not the best one. And then we normally, this is what I do, I think about it. When I go home on my bike, under the shower, I'm thinking about this design, this solution, and I start to have ideas, and I discuss this with my team and with the other people who have the role of the architects or developers, all of them. And very often we find a better solution. We have this, oh yeah, we should have done it like this. This is the solution. This is the better design, the better architecture. And then we need time to improve the system. and to eliminate this accidental complexity that we have built in. And these are the green arrows that go downwards. So we get this development, a little bit more complexity, improvement again, and so on. This is good legacy. This is easy to understand, easy to change, and easy to maintain if we can live this cycle of changes and improvements. But if we don't get the improvement time, the architecture will erode and more complexity will pile up. The arrows here are turning from yellow to red, and they are getting shorter and shorter because we are getting less and less new functionality done per time unit or per budget. The development is gradually taking hold, and then we arrive in this corridor up here of high and non-predictable maintenance cost. You might know this situation. Nobody really wants to estimate the cost for a change anymore because we don't know where we end. It's too complicated. It's too complex. And actually, nobody wants to change the system anymore. Do we have to do this? Oh, can't it stay like it is? It's working. Yes, you have to do a little workaround in your daily work, but it's so dangerous to change something because we have the feeling that the system is falling apart, and very often the teams are falling apart as well, because developers in these situations tend to leave the sinking ship. So this is bad legacy. If you are up there, it's frustrating. But there are ways out. Actually, there are two ways out. The first one is here. You can do a lot of refactoring to get your system downstairs again towards the good legacy, or you can rebuild the system. Both paths are in general expensive and hard work. You have to do something. And very often, from my point of view, rebuilding the system is really a tempting solution because, like almost any of you, I love to explore new solutions. It's so much fun to start again, to redo something, to rethink it. But actually, over the last years, I have experienced two important reasons why we should really question our desire to build something new. The first is that we really underestimate the task of rebuilding. We think, oh, I'm replacing the legacy system now, and the way is very clear. But after a while, on our way of rebuilding, it becomes obvious that it's not so clear. There is quite a lot of functionality in the legacy system that was not described anywhere, and we have to dig deeply into the forest, or we have to find those functionalities in the sea or wherever in this picture. We have to talk to various groups of users to find out if anyone still needs this functionality, but often someone does. And then we become aware of users who export data from our legacy system and use this data in Excel or in Access, or they just email the data to someone else. And all these hidden steps are actually important for our business processes. The users are doing this because they want to fulfill their job, but we often don't know about them. Of course, we try our best to get close to all these areas of knowledge, and I put them here for you to discuss this. If we want to rebuild a system, then the easy part is the things where we know what we know, that we know them, the known knowns, and the things actually where we know that we have a gap in our knowledge. So the known unknowns. Unknown unknowns, this part down here, is a bit difficult, but not that bad. Those are mainly features that we take for granted. That's why we don't even think about them. And in general, someone will point this out to us during development. Things like, well, users have to be have to do some login. Don't forget that. Oh yes, I didn't even write that down. Of course, we have to have that. So unknown knowns are these features. The most difficult part of knowledge is the unknown unknowns, features we don't know that we don't even know about. I once helped a company to discover their unknown unknowns for a software system. This was a container terminal operation system, and it was very old and written in a programming language that was about to lose support. So we decided to extend the legacy system with a logging mechanism. This was very easy in this system, a logging mechanism for all functions that were called in the system. So we let run the logging mechanism for a year, and it told us all the functions that were used. And after that year, everything that was never used was taken out of the system, that was turned off. And actually, it was amazing. We could get rid of about 30% of all functionality of this system. So we had a quite smaller system to replace. You might ask yourself now, but why did I do it for a year? A year is a very long time. Well, this system was not just used for the operation, but also for all the annual regeneration of data of the factura and all that. So we had to wait for New Year and the time after that to really see all the functions that were called only at New Year to finish all the yearly tasks. So this was our solution. It worked well, but of course it took a year. And on top of that, there is another huge problem that I see with rebuilding legacy software. And this is that the project team members, they are all focusing on building a new system. They put all their energy and their love and their intelligence into this wonderful new thing, this wonderful new software solution. And of course, by doing this, they will as well think about new user interfaces with a new fancy front end where everything is much easier and much more pretty and good looking. And well, everything will be brand new and wonderful. And we expect that our users will all be happy, delighted, and that they will praise us for our good ideas. But unfortunately, very often our users are not happy at all about this really big change. Everything is different. They stay in front of this new system and they feel like old fools. They don't find the features in the new software which they used in the old software to actually do their daily work really, really quickly because they knew their way around. And now they have to search everywhere. But all they really want is to do their daily work. They just want to work. They are not interested in a wonderful new system. This makes our users beginners again, which is very a frustrating experience for anybody. And this is where people start to show a very stubborn behavior, and they tell us, but that was solved much better in the old system. So please don't underestimate the cost of changes in an organization for the users, for the whole organization. It is really hard to bring users and organizations along. In general, from my experience, this normally doubles the price. You know, you have a price for the rebuild of the software system, and the same amount of money is necessary to change the organization. So maybe refactoring is not such a bad idea after all. What you see here in this picture is the Elbphilharmonie in Hamburg. It's a concert hall built the last 10 years, which now rises 110 meters into the air directly at the port of Hamburg. So if you come to Hamburg, please visit it. It's really, really a beautiful building. But the Elbphilharmonie is not a new building. As one might assume at first glance, this looks all very new, but the Elbphilharmonie is a refactoring. The lower section of the red bricks that you can see there were already in place when they decided to build the concert hall. This part is an old warehouse that was gutted for the construction of the Elbphilharmonie and integrated into the overall building. So to say, the overall building was built on top and inside. Can we do this with our software systems as well? Can we do such a wonderful refactoring? Well, fortunately, software is even easier to refactor than buildings due to its non-material nature. And in software, we can improve in small steps where you always keep a runnable software. Let's have a look at these steps that I normally propose to my clients with their legacy. Legacy code has many problems, such as bad design and architecture, bad implementation, many bugs, and very often also a low security level because libraries have not been updated for years. And sometimes even the support for various libraries does no longer exist. I see that over and over again. And on top, an automated build or a deployment pipeline does not exist either or is in a pitiful state. So we always start at the bottom of the whole thing. And to get a better security and an infrastructure level, we have to do dependency checks and implement a modern deployment pipeline. This is always the first step of improvement that we do because they normally don't change the functionality of the software, but they really improve the quality of work, the quality of our feeling about the security, and of course the quality of work. We want to change quickly and deploy quickly, so we need a good deployment pipeline. And now our system still has many bugs: a poor implementation, bad design with dubious architecture. And then we take the next step of improvement. And this is to introduce tests on all levels. This way, we create the fundamental basis for all the steps afterwards. You probably all know JUnit, a wonderful program invented in 1997. So it's already 25 years ago by Kent Beck and Eric Gamma. They were on a plane together on their way from Zurich to Atlanta. And what do two geeks do when they have such a long flight? Well, they program, of course. And so JUnit was actually developed with pair programming, which is also a wonderful story. JUnit automatically runs tests that you have programmed. And if everything is good, the bar turns green. And if there's an error, the bar turns red. And of course, no one can afford to write tests for the entire existing source code base. I don't propose that. The thing I want to propose to you is that you follow the Scout rule. Let's have a look. The real Scout rule says that a group of scouts, when they are setting up their tents for the night, then the next day they must clean up and leave the place in a better condition than upon their arrival. And if we apply this Scout rule to software development, then putting up the tent for a night translates to a software developer has to change source code to resolve a bug, to do some planned refactorings, or to implement some new functionality. And his cleaning up job here is while he or she is doing a change, they have to implement tests and do the necessary refactorings to leave the source code in a better condition than upon the beginning of their work. I have quite a nice story for you that relates to that. I remember a legacy software where we had secured quite a complicated algorithm step by step with unit tests. And the rest of the source code was still without any tests. And now, if anybody found an error in this algorithm, in this well-tested, quite complicated algorithm, we were actually happy. We could make this error visible with another test and then fix it. The new test was then another rope in our safety net for this complicated algorithm. And in this really well-tested part of the system, it was a lot of fun to do refactorings. And it was so strong to see how this part of the system was nice to work on, to change, to refactor, but the rest of the system was so difficult to move on. So if you do that, this will be a very good and convincing starting point. If you get this feeling for one part of the system, your colleagues and you will feel how good it is to do unit testing, and you can go on. Of course, we have invented a lot of other tests. We have added 2 more levels of test, integration test and UI test. And this looks like a lot of work, but anyone who has worked on a project with good test coverage will appreciate the increasing number of tests in your legacy. And the software will live again, which means that we can change it. The next step is an improvement on the implementation level. Here, metric tools and code reviews are used to find weak points in the implementation, such as long methods or algorithms that are much too complicated. Dashboards that many development teams are using today are, for example, SonarQube or TeamScale, or you name it. Such dashboards often report a very large number of problems in the implementation. And my advice for working with such dashboards and improving the quality of the legacy is, first of all, deal with the size metrics. The metrics that tell you that something is long or big or has too much complexity. Focus on these large building blocks, the large classes, the large methods, the large packages, the large modules, whatever you have. Focus on those large building blocks, and those of these large building blocks that are conspicuous because they are so big, they are almost always a sign of a poor implementation and poor design. So please start with them and test and refactor these large units so that you can break them down into smaller ones. Of course, testing is in here again. This is a very good first step. And then, of course, we have to deal with the last step of improvement with the design and the architecture. The thing that we do here is that we do architecture reviews, where we examine how the architecture and the design of the system can be improved so that it is more sustainable, that the architecture is better, that the design is easier to understand. For this, you need some tool to do the analysis. I do this a lot with our colleagues for our clients. You can use TeamScale, Structure 101, the SonarGraph, LaTeX. They are wonderful tools to help you with that, to see your architecture from a higher point of view. If you have tool questions, I can definitely answer them afterwards. All these tools need to cost money, of course, because open source tools are in general not that sophisticated to do this architecture work. But how do we, I mean, what do we do then? What we do to tell people where they are is that we give them a grade from 0 to 10. We call this the modularity maturity index. And with this, we can evaluate the complexity, how high or low it is, of the architecture and the design, and we compare it with other systems. On the x-axis, you see a rating from 0 to 10. If the modularity maturity index is between 0 and 4, the system is in a quite poor condition at the architecture and the design level, and it will probably be in the corridor of bad legacy. Between 4 and 8, the result is mediocre, and between 8 and 10, it is good. And of course, everybody wants to be between 8 and 10, I think. And here I show you 16 systems that we have put together as an example. On the y-axis has really no other meaning than the time course. We have analyzed these systems one by one and put them on the slide to have an overview one by one on one unit on the y-axis. What you can see here are 16 systems in different programming languages. The green one up here at the top left is a Java system, but the red one down here is as well Java, and this one as well. And this one is C#, and the big one up here is C# as well. There is as well PHP, C++, and TypeScript. The programming language actually is not responsible for the result in the modularity maturity index, but the knowledge of the programmers and architects about sustainable software architecture. And in the course of these analysis, we in general teach the programming team a lot to understand what to do, how to get to a better architecture that is sustainable and that will live for a long time. I have another topic that I'm working on at the moment, that I'm trying to discuss here with you, because the last idea for legacy systems that I want to share with you here is the question, well, Jesus, where do we start if we have a huge landscape of various software systems and basically all of them are legacy? And I want to give you a little glimpse into domain-driven design for the last bit of my talk here, because domain-driven design will help us here. When we build a software system for a domain, or we have several software systems, this is possible, of course, as well, we decompose the domain into subdomains. This is what domain-driven design tells us. Look at your domain and find subdomains, things that belong together from a domain perspective, that form a proper connected functionality, that support the user in one work area. And in the software, please build bounded contexts that fit to each of these subdomains. So, and the other thing in there in domain-driven design is ideally each bounded context will be developed by a separate team so that they can really focus on their functionality. But now, if we have this big landscape of legacy software, how many it ever might be, but in here just 3, well, where do we start? Which is the one we start to improve in the first step, or do we do it with all of them? No, I would always ask you to start with one of them, and I will now show you which one this is, because domain-driven design names 3 different types of subdomains, and that can help us to find out where to start. There is the core domain, the supporting domain, and the generic domain. And the core domain is the part of the domain that determines the success of our company. with its excellent work and its special offers in this part of the domain, our company will distinguish itself from other companies and is perceived as the wonderful and special company by all its customers. Some of you might know the word unique selling point. For our company, the core domain where we are the best, where we distinguish us from other companies, this is our unique selling point. And to keep it that way, the company needs the best possible software solution in its core domain, so that company can stand out at this point. Everybody will see, wow, they are perfect. The system or the systems in the core domain therefore have the highest priority. For a banking domain, for example, we could determine in discussions with the domain experts. Of course, you have to discuss this with the domain experts. Where is the core domain? We could maybe find out that account opening is the core domain, because this is the part of the software that should make the work with the client the most efficient, the most pleasant and fast, and the user will be, the client will be happy that we are so easy in opening bank accounts. Maybe it's even a web front end, and he can open his bank account online. The supporting domain is the part of the domain of which our company needs a particularly specialized solution, but which is less important than the core domain. In our banking domain, there is an external card manufacturer for the credit card protection. And since the customer will use his credit card every day, it has still some special importance for us as a bank. And so the bank has its own department that handles the design of the credit cards with its own graphic programs before providing them to the card manufacturer. So we can consider this part of the domain a supporting domain and prioritize it accordingly. Finally, the generic domain is the part of the domain of which we can use for which we can use a generic solution in our business. We need a solution that that is not specialized for our business, and that we can buy and plug in, probably a standard solution that we can get from outside. In our banking example, the creditworthiness is checked via an external service provider, and this part of the domain is a generic domain. We don't have to be excellent there. We don't have to differentiate us from our competitors. This is something that we just need for our bank, and we're going to integrate it. A separate development with own database and all that does not make any sense for us. So if you are faced with a decision of which of the existing legacy systems to improve first, then choose the system that is used in the legacy, in the core domain. Choose that part of your software, and I hope you can start a discussion in your company about the domain and the subdomains that you have, and can find that part of the legacy solution that is the core domain, and you can invest in there and start to work on that part of the system. I hope that I have given you some insights in my ideas about legacy software. Of course, there is much more to know. I didn't talk to you about our cognitive mechanisms to deal with complex structures, about microservices, about a lot of tons of knowledge of domain-driven design, but you will all find this on this conference, I'm sure, or you can look into my book, of course. And now I'm ready for your questions. So here I see some questions.
Hello, Carola. Thank you so much.
Hi. It was a
All right,
pleasure.
we
Thank
have
you for
a
listening.
no, so happy. I was so enthralled that I didn't catch you at the end there. So we
No
have a
problem.
load of questions, but let's take
Perfect.
about 5 for now, and maybe
Yeah.
if you have time, the additional questions you can answer and hop in. All
Yes,
right,
I will do that.
our first question. After all the years analyzing systems and getting to know software teams and organizations, do you see a positive or a negative trend when it comes to allocating enough care and time to sustainability?
Yeah, well, trends are difficult because, of course, people call me in general when they have problems. So I actually see the negative examples. But what I can see is a little bit of a cultural change. I think that we are at the moment in a time when management understands as well more and more that you have to invest money into the software and that you have to put in time and care for the sustainability of your software. So I have some hopes. But of course, I see as well that all over the place people are creating new software and they don't know much about sustainability. So we are running behind the wave, so to speak. It's not so easy. So I'm sorry, I don't know if there's a trend, but I see cultural change, and that's already something.
Very, very interesting. All right, let's go to our next question. In a legacy system, how can you counteract promotion-driven development? For example, building the new shiny thing versus refactoring and redesigning an old one.
Yeah, very good question. My answer is maybe a bit hard. What you have to do is you have to promote the refactoring and the redesign. And actually, normally you can only do this by creating some numbers for cost. And what you have to start with is you have to find a way to give your team lead, your manager, whomever, a number what the problem actually costs, the issue, the thing that you want to refactor. It's so difficult to change this. So each bug that I have to fix takes double the time than I would love to. And you have to put a number on that and say, well, this problem cost us that money every day. And if we find a solution, if we replace this old library, if we have a building pipeline whatsoever, if we have some tests, this will be much less expensive. And if you can do that, and if you move on this level of promoting your refactoring, even if this is nothing we like, because we just want to do it, we don't want to think about the money all the time and think about how could we explain how much this cost. But this is the only way I know to promote refactoring and redesign and to work a bit around these new shiny things. But it's hard, I know.
Okay. How do you go about calculating the MMI? What do
Yeah.
you consider to come up with this
Yeah,
index?
I didn't dive into this today because I didn't have any time. There are some speeches on the internet where I talk a little bit more, go a little bit more into detail. It's based on my doctor thesis where I've looked into cognitive science to understand what is difficult for our brain to grasp. So there are some things that our brain is doing to get along with complex structures. And we have ideas in software development like modularity, hierarchies, patterns to help our brain. And if the software is built in that way, it helps our brain to understand, and it's much easier to change and develop. And then the modularity maturity index is good. This was just a short explanation. In my book, there is more. I'm about to write a chapter for another book where I explain it even more in detail. We have a big database of all these data to compare software systems with the MMI. But I mean, there is some information out there, and we are about to put out some more information in the next few months, I hope. It always takes time, you know.
Of course, that's fantastic. Where can folks find this new information?
Well, I'm about to write a chapter for a O'Reilly book on metrics, and the next version of my English book will have this information as well. I have to respect the editors, you know. I can't just put it out there because they need it for the new version of the book. But if anybody has detailed questions, just send me an email or contact me on Twitter, and we can discuss in detail.
That's fantastic. Thank you. Our next question. Did you notice a shift in the nature of software complexity? I feel like people tend to jump on the microservice buzzword train way too often.
Yeah. I'm absolutely with you. Microservices were a good invention at the time, 2012, when they came up. We had the problem of scaling legacy systems. We still have. We're not safe yet. But just to walk around and say with microservices all our problems are solved is not the good answer. There is already a big change if you reorganize your source code in a modular way, and you don't always need microservices. You need them if you want to scale, but for a good architecture and sustainability, you don't need it to reduce complexity. It's not the good idea to reduce complexity because with microservice architectures, there is this whole deployment story, and you have you are not in the same source code, and you have to follow the events and find out what is happening where. So you create even more complexity, and you have to always, if you put in more complexity, ask yourself if it's really, really, really necessary. It's not just fun, you know, like you all know. So absolutely right, this question and sentence. Yeah.
All right, our final question for now. How did you analyze modularity?
Yeah, how do I analyze it? This is a bit the same answer. I had the chance to write my doctor thesis, and I wanted to work on complexity of architecture. It was a colleague who gave me that idea, and I had a really, really great professor, a woman, Christiane Floyd, who was the first female professor in computer science in Germany. And she had a profound knowledge of modularity and really discussed with me, how can we get closer to this? What is good modularity and why? And we had no other solution than to go into cognitive science. If you know German, you can read my doctor thesis. It's even more complicated, of course, than the book. We look for things with high cohesion and loose coupling. This is actually the shortest definition of modularity from my point of view. I want things to have high cohesion and low coupling, and then we have modular structures on all levels. Cognitive science has a lot to do with that.
Great. Thank you so much for the wonderful answers to the questions, and your session, as always, was absolutely fantastic.
Thank you, Alison.
We have loads more questions on Hopin.
I will go there.
Okay.
Answer that. I'm happy. I'm happy about a lot of questions. This is always wonderful.
Yeah, I wish we had more time to go through all of them. As you mentioned, you're available on Twitter and email.
Yes.
So if anyone wants that information, please reach out. Happy to help share that.
Yes. And you will find me on the internet. It's not complicated to find me.
Okay.
So
good to know.
Thank you very much, Alison.
Thank you for your time. See you next time.
It was a pleasure. Yes. Bye-bye.